January 27, 1967. Cape Kennedy, Florida. The sun has already gone down over the launch pad, and inside a gleaming white space capsule sitting atop an unfueled Saturn IB rocket, 3 men are strapped into their couches, running through what everyone on the ground believes is one of the safest tests in the entire Apollo program. It is called a plugs-out test, a full rehearsal of a launch countdown, done without a drop of fuel in the rocket, disconnected from all external power, running purely on its own internal systems. On paper, it is routine. In reality, it is about to become one of the deadliest afternoons in the history of American spaceflight. The 3 astronauts inside are among NASA's best. Virgil Gus Grissom, the command pilot, is a veteran of Mercury and Gemini, one of the original Mercury 7, a man who has already flown in space twice and cheated death once when his capsule sank in the ocean after splashdown. Ed White, the senior pilot, is a national hero, the first American to walk in space, a name and face known across the country. Roger Chaffee, the pilot, is the rookie of the crew, an engineer and Navy officer about to make his very first flight. Together, they are set to fly Apollo 1, the mission meant to kick off America's crew journey to the moon. But that afternoon, nothing about the test goes smoothly. From the moment the astronauts are sealed into the command module, hours before the fire, problems pile up one after another. There are strange smells in the spacesuit oxygen system that force temporary holds. Communication systems keep glitching, cutting in and out between the capsule, the blockhouse, and mission control, making simple exchanges maddening. At one point, frustration boils over, and Grissom's voice crackles through the static with words that would become tragically famous. How are we going to get to the moon if we can't talk between 2 or 3 buildings? Nobody listening that day imagines those technical headaches are a warning of something far worse. The test continues, hold after hold, delay after delay, as the clock ticks past 6 in the evening. Inside the capsule, the environment is a ticking time bomb, though no one fully understands it yet. NASA has filled the cabin with pure oxygen at a pressure higher than sea-level atmosphere, a design choice made for earlier programs because it simplified spacecraft engineering and worked reliably in the vacuum of space. But on the ground, before launch, under normal atmospheric pressure outside the capsule, that pure, overpressurized oxygen environment is extraordinarily dangerous. In ordinary air, materials that are hard to ignite become almost explosively flammable in oxygen at this concentration and pressure. And the cabin is packed with exactly the kind of combustible material that turns this into a death trap. Nylon netting used for storage, foam padding lining the seats and walls, hundreds of feet of wiring snaking beneath the floor and behind panels, some of it insulated poorly, some of it already showing wear from the number of times the capsule has been opened, closed, and reconfigured for tests. At 6:31 in the evening, everything changes in an instant. A voice from inside the capsule, investigators later believe it was Roger Chaffee, comes through the comm system. Fire. I smell fire. Only seconds later, a second, more urgent voice, Ed White's, cuts through. Fire in the cockpit. Somewhere near Gus Grissom's seat, an electrical spark, most likely from damaged or exposed wiring beneath the equipment bay, ignites in that saturated, high-pressure, pure oxygen atmosphere. And in an environment like that, fire does not behave the way it does in a normal room. It does not creep. It does not give people time to think. It erupts. Flames spread almost instantaneously across surfaces, racing through the cabin in a matter of seconds, consuming the flammable materials that surround the crew on every side. Temperatures inside the tiny sealed capsule spike catastrophically fast. The astronauts try to do the only thing they can, get out. But the hatch of the Apollo command module is, by design, a nightmare to open quickly. It is not a single simple door. It is a complex, multi-layer, inward-opening hatch system, engineered with multiple bolts and latches specifically to ensure an airtight seal strong enough to survive the vacuum of space. Under the best possible conditions, with a fully trained ground crew calmly working through the procedure, opening it takes a minimum of about 90 seconds. Under panic, smoke, and heat, it is essentially impossible in the time available. And it gets worse. As the fire rages, the temperature and pressure inside the sealed cabin shoot upward, and because the hatch opens inward, the The mounting internal pressure presses it shut even harder, sealing it further just as the men trapped behind it need it open more than anything in the world. There is functionally no way for Grissom, White, or Chaffee to escape in the handful of seconds they have. Outside, on the launch pad gantry, the ground crew and pad technicians hear the shouts over the intercom and see the reflected glow and rising smoke through the capsule's small windows. They race toward the spacecraft, but they are met by a wall of heat, a cabin filling with thick black smoke, and a very real fear that the fire could spread and detonate other systems on the pad, endangering everyone nearby. Wearing no protective fire gear suited for this, some of them still push forward, trying desperately to reach the hatch mechanism, choking on smoke, burning their hands on hot metal, working blind through diminishing visibility. It takes several agonizing minutes that feel far longer to the men fighting to get in, before the hatch is finally pried open. By the time it is far too late. All 3 astronauts are gone. Medical investigators later determined that the crew did not die primarily from burns, though their injuries from the flames were severe. The true cause of death, investigators conclude, was largely asphyxiation. The fire, in the sealed, oxygen-rich cabin, consumed the breathable atmosphere and produced toxic combustion gases so rapidly that Grissom, White, and Chaffee lost consciousness and died within seconds to at most a couple of minutes of the fire igniting. There was almost no window in which rescue, even a faster one, could have changed the outcome. Word spreads through Cape Kennedy, then through NASA, then through the country, like its own kind of fire. The mission meant to be the triumphant first crewed step of the Apollo program. The mission meant to carry America closer to President Kennedy's promise of a moon landing before the decade's end, has instead become a funeral. 3 of America's most accomplished astronauts are dead, not from the perils of spaceflight, not from some catastrophic failure 100 miles above the Earth, but from a fire on a test pad, sitting still, with no engines firing and no rocket fueled. The nation is stunned. NASA, an agency that had, until this moment, moved from triumph to triumph. Mercury, then Gemini, method after method of pushing further into space, is suddenly forced to confront the fact that its ambition has been outrunning its caution. A review board is convened almost immediately, and what it uncovers over the following months is damning. The pure oxygen environment, long known within engineering circles to carry serious fire risk on the ground, had been accepted as a manageable trade-off for years, without sufficiently rigorous fixes. The hatch design, prioritizing the airtight demands of orbital survival over the emergency escape demands of a ground test, had never been adequately reconsidered for a scenario exactly like this one. Wiring inspections, documentation, and quality control on the spacecraft were found to be inconsistent, with debris, loose materials, and unresolved defects found scattered throughout similar capsules. The investigation paints a picture of a program racing toward a deadline, a program under intense political and public pressure to beat the Soviets to the moon, where safety processes had not kept pace with the speed of development. The response, though it comes at the highest possible cost, reshapes the entire Apollo program. Engineers scrap the old hatch design entirely and replace it with a new, quick-release, outward-opening hatch that a crew can open in seconds, not minutes, and that responds to internal pressure by blowing outward rather than sealing tighter. The ground atmosphere inside the capsule during testing and pre-launch is changed from pure oxygen to a nitrogen-oxygen mixture much closer to normal air, dramatically reducing the fire risk while still allowing a shift to pure oxygen safely once in the vacuum of space. Nylon netting, foam, and other combustible materials throughout the cabin are replaced wherever possible with fire-resistant materials. Wiring is re-inspected, reworked, and better protected. Testing and safety procedures across the entire program are tightened, with a level of scrutiny that had simply not existed in the same way before January 27, 1967. It is one of the most painful ironies in the history of human spaceflight. The fire that killed Gus Grissom, Ed White, and Roger Chaffee on the ground, in a spacecraft that never even left the launch pad, very likely saved the lives of every astronaut who flew afterward. Just over 2.5 years later, in July 1969, Apollo 11 carries Neil Armstrong and Buzz Aldrin to the surface of the moon and brings them home safely, flying inside a command module built on hard lessons that were paid for in the worst way imaginable. The successes of Apollo 8, Apollo 11, and every mission that followed rest, in part, on the wreckage of Apollo 1. NASA renames the mission Apollo 1 in official recognition of the crew's sacrifice, even though it never flew. Their names are carried forward on every subsequent Apollo mission patch tradition, remembered at Kennedy Space Center, honored at Arlington National Cemetery, etched permanently into the story of how humanity reached the moon. Gus Grissom, Ed White, and Roger Chaffee did not die exploring the void of space. They died on the ground, in a test that was supposed to be safe, victims of a fire fed by decisions made under pressure to move fast. Their deaths forced NASA to slow down, to rebuild, to take spaceflight safety seriously in a way it never quite had before, and in doing so, they became, in the most tragic sense possible, three of the reasons the moon landing ultimately succeeded.